ever wish that your students were begging to solve more word problems? It has happened. I've seen it happen in a grade 4, grade 5 class where the beginning of the year we give them these word problems and they're in tears, we don't know where to start, there's no buzzwords. And then we teach them a process of model drawing. And the kids, it empowers them, and by the end of the year they're saying, we want more, we want harder, these aren't hard enough, and never thought the day would come, but it's here. How do we get them there? Let's look at the process of model drawing. Singapore uses the approach, this idea of using a bar to build comprehension in the problem. It's a tool to get started with how to go about a word problem when it just seems like there's a lot going on. We remember the word problems in algebra. You know, if Johnny had 3 more than his friend Susie, and Susie gave some to Johnny and whatnot, the more words there were, the more intimidated we got. We gave up, we didn't want to try. So let's see what we can do to help get over that. Let's look at our first problem. Here we have our culprits, Spiky, Curly, and Buzz. They're back. And what do we know about them? They have 557 marbles altogether. So using a bar, the idea of a rectangle, in this case a square, we could use 3 different ones in a comparative way to talk about our friends. We have Spiky, Curly, and Buzz. I'm just using 3 different colors to represent my 3 different friends. Some teachers might draw pictures to help us know the differences between Spiky, Curly, Buzz. Spiky has 3 times as many marbles as Curly. Curly has 2 fewer marbles than Buzz. How many marbles does Curly have? So again, really wordy. Spiky, Curly, and Buzz have 557 marbles. That might be easy for a student to start with. So we could show that by putting our 557 as the total amount that the 3 friends have. What else do we know? We know that Spiky has 3 times the amount of marbles as Curly. So does our model show that? Hopefully students will see that this is the same amount, or we can say it's a 1-to-1 relationship. If we need Spiky to have 3 times as many as Curly, can you imagine whose bar we would add to? Let's see. Did you guess Spiky, Curly, Buzz? If Spiky has 3 times the amount as Curly, we could show 2 times, or double the amount in this way, and then we could show 3 times, or a 3-to-1 relationship. So far, if we go back and read, we know that Spiky, Curly, and Buzz have a total of 557 marbles. Spiky has 3 times the amount of marbles as Curly has. We also know from our next sentence that Curly has 2 fewer than Buzz. So right now, visually, does that show what was represented by Curly having 2 fewer? So in 4th grade, some kids will extend one friend's bar or the other, and others might just say, 2 fewer, I could show that Buzz has 2 more. I could also show that Curly, I could do -2 to show that Curly has 2 fewer. If we decided that approach, we may need to adjust Curly. So here, we have all the information that's given, and they're asking us to figure out how many marbles does Curly have. So as always with a model, we have a tool to get us our math equation. Could you imagine what that equation would look like? Some people want to jump right to algebra because they can see unknowns. why might a student say that 5 units plus 2 more would be the same as 557? Do you see where the 5 units are coming from? In algebra, we call that 5x. So we can see these 5 unknown pieces and 2 more would give us our total or our whole. So a 4th grader doesn't know Algebra 1 at this point, does not know what you do to one side, you do to the other, and all those rules and procedures, steps we teach kids. But they do know that this part and 2 make a total of 557. So they ask themselves, what number plus 2 gives me my whole? Or if I know my whole, I can subtract the 2 to figure out this amount. So you would see students say that 5 units would be represented by 555. And then in order to find that 1 unit, they would divide that 555 divided by 5. So what we've done here is we've taken a word problem that seems to have a lot going on. We've used the tool of bars or model drawing that incorporates the bar model to help us make sense. We show the relationship in a comparative way, but we also have here that Buzz has 2 more than Curly. We're solving 2-step equations without having Algebra 1 because we can see the part-whole relationship in this problem. Let's look at another high-level problem. In our second example here, we have Spiky and Curly buying a shirt. So let's read the problem. At first, Spiky had $90 and Curly had $42. Can you imagine what that would look like if you had a bar? Whose bar would be longer? How much longer? Would it be double, half, 3 times the amount? They then go and each buys a shirt at the same price. As a result, Curly has 1/5 as much money as Spiky. How much did Spiky spend on the shirt? Again, we don't see buzzwords here. You have to understand what's going on. So using our bar model, I'm just going to choose 2 bars. Do you know why I chose 2, not just 1? Can you read my mind? Because we have Spiky and we have Curly. So one of our bars will represent Spiky, and one may represent Curly. And often I'll do this and I'll wait for kids' responses. And what do you think they're saying? You guessed it. That's wrong because it looks like they have the same amount. We know from our problem that Spiky has $90 to start with and that Curly has 42. And if this is 90, then that bar can't be 42 because it looks the same. And so some kids, 42, they might say, oh, a little less than half. That's what we're aiming for. We want that number sense, that proportional reasoning for kids to be able to talk about the relationship between 90 and 42. So if this is 42, which is what our problem tells us they start with, we know that each of them goes to the store and buys a shirt. And what do we know about that shirt? We know the shirt is the same cost. So if this is the cost of the shirt, we have 1 here and 1 here. Actually, it's a cost of a shirt, so we probably don't want to add that in, probably want to subtract that. So instead of putting it there, maybe we say that it's here. We know that's the same amount, and that's a shirt. We also know as a result of buying this shirt that whatever's left, so if we look at this amount that's left, and I'm just going to drop it down here, and some people refer to this as the after model. So what was left after, let's see if I bring this down, is this type of relationship. So after they go out, here's Spiky, here's Curly, and we know something about this. We know that Curly has 1/5. So if I drew a somewhat good bar here, and of course, I'm a little off in that spacing, but if you can imagine 5 equal parts here, so maybe my bar extends a little bit more here. So 1, 2, 3, 4, 5 pieces. You get the idea. We can see that as a result, Curly has 1/5 of the amount. We also know that the 90 and the 42 from the beginning has to come into play. So this is where I say we have a turning point going on here. Some kids might stop at this point and they might say, I don't know what to do now. Well, what do we know? We know 90 and 42. What is it that kids have to see in order to solve this problem? Are you seeing it? Before they bought the shirt, what we need to notice here is that there's a difference. And this amount that's the difference is what? We can say $48. And so this amount that's 48 is saying that the difference between their amount of money is $48. When I go buy the shirt, whatever that shirt is, the difference, which is seen right here, the difference between this amount also still needs to be $48 because they bought the shirt for the same amount of money. So from here, this is what I refer to as the turning point, because now, if I drew a better model here, not helping you visually, you could see that 4 units equal the $48. So I know your brain just probably has exploded in trying to figure out this 48 and how it came into play. So let's rewind a little bit. We know at the start that there's a relationship between 90 and 42. We also know that we could say Curly has $48 more than Spiky has $48 more than Curly. When they go buy a shirt, we don't know the cost of the shirt, but whatever they have bought, we know that the difference between this amount, the difference, because say the shirt's $10, they both spent $10. So there's still a difference of $48. And that 48 has to represent these 4 units. When I know those 4 units are 48, then I can figure out how much the shirt was, how much Curly has left, how much Spiky has left, etc. This is an example of a before and after type of problem that had what we call a turning point, something that you had to see in it to use and solve it. This is what we would refer to as a little model drawing 201 because it's a little bit more advanced than your basic part, whole, or comparative model. We got one more to look at that might feel a little bit easier in using a bar model. So the next example, Curly spends 1/5 of her savings on a book. So if this was her savings, could you imagine what she would fold this into? If you guessed 5, it's probably a good choice. And I would ask my students, why 5? Why do you think 5 would be a good choice? So if Curly spends 1/5 of her money on a book, and then she does something with the rest. So most of my students can get to this point pretty easily in showing, here's Curly, this is the amount of money, and they could show 1/5 of her money. And they might even put a B for book. And then it says that she did something with the remaining part of her money. What did she do? The 3/8 of the remainder she spent on a gift. So, some of you know what you would like to do. Others aren't seeing it. So one strategy is just to drop down the remainder. So if this is the remainder, we know that she spends 3/8 of this on a gift. So we might cut that into 1/8. And so if we have 1/8 here, we know 3/8 of it on a gift. Gift, gift, gift. It also tells us that she has $60 left. So this could be the $60 that remains. And so we can see 1, 2, 3, 4, 5 units. Again, algebra 1, 5x is the same as 60. And so by looking for what 1 unit is, students would divide the 60 by 5 to give us our answer of 12. And once we got our 12, we could then go ahead and answer how much was the cost of the book. I hope you can see how if these were 12s, how that would help us transfer it up here, and then how that could help us figure out the book. So the bar model is not necessarily to give us the answer, but a tool. Kids see this as a puzzle. What do I have to do? Where do I start? You start by just saying, what do you want the bar to represent? We wanted it to represent our savings. We knew something about the savings, and we took it one step at a time to kind of decide what each of these would be, and then we worked backwards to figure out the amount of the book. So in model drawing, at some point, not in 1st and 2nd grade, but 3rd, 4th, 5th, upper grade levels, you need some tools to figure out word problems when they seem to get really wordy and difficult. Using a bar model is one tool that has proven to be successful. How does Singapore go from 46% of their kids not being able to solve word problems to more than 50% of their country being able to solve the highest level word problems on international studies? We in the United States have to move away from teaching with buzzwords and focus more on tools to help us get to the math equation and then interpreting what these results mean. Hope this helps in seeing how a model will help build comprehension in a word problem.